Hello there! In this tutorial we are going to finish this Mario-style platformer, and there are three major parts I am going to work on. The most important one is the collision detection. Then I also want a countdown timer before we can start in the overworld, and finally I want to add sound. And I suppose we can jump straight into the first part, so let's talk about the collisions. Right now the collisions do kind of work, but they are not great. There are quite a few bugs with the player teleporting around when colliding with an obstacle, so that's already kind of annoying. And on top of that, we also check the entire square around the player for collisions, which could mean that the pirate itself is floating in the air because the sword is colliding with something else, which is obviously looking very silly. Fortunately, these two problems can be fixed together, and here's what we are going to do. Instead of checking for the rectangle of the sprite class that covers the entire pirate and the sword, we are going to create a whole new rectangle inside of the pirate class. And this new rectangle is only going to cover the pirate himself, so it is not going to cover the sword. And then in our level, this is going to be the rectangle we actually control. And this will also be what we are using for the collision detection with the level. Now we are still going to keep our sprite rectangle because we always need that. But instead of controlling this one directly, we are just going to make it follow our inner rectangle, the one that covers the pirate. And this way we can create a system where the sword isn't part of the collisions with the terrain. However, if the pirate is colliding with an enemy or a coin, we can still use the sprite rectangle, which I think makes a bit more sense here. So essentially, we are going to check different kinds of rectangles for our pirate, which is quite a powerful system. And by the way, if you want to create a Zelda-style top-down movement game with overlapping elements that convey depth, you will need a similar kind of system that separates the drawing, the positions, and the collisions. It does get a tiny bit more complicated. I will do a tutorial on that eventually. And do get subscribed to not miss that. But with that, let's jump into the code and let's fix our collisions. Here we are in the code, and right now I only have 4 files open. So main, level, overworld, and player. Those are the ones we really are going to need for this tutorial. And I want to work in my player for now. And in the player, we already have quite a few different functions. And for now, I want to work in the init method. And what I want to do in the player movement section, I am going to create a new rectangle. And this I have called collision_rect. And this is literally just going to be pygame.rect. So just a normal rectangle. And now for this rectangle, we need a position and a size. And both of these have to be tuples. Now for the position, I'm just going to use my self.rect.topleft. So essentially, let me draw on the screen. This is our self.rect. So the self.rect we create early on, this one here. Essentially, what I'm going to do with this collision rectangle is for now to spawn it in the top left here, and then make it cover only a certain width. And this is going to be the width where we have our pirate. And then the other half is going to be the sword of the pirate. And for this, we don't want to check a collision. So this is the part we want to exclude. And all right, so with that, we have a position. Next up, we need a size. And this is also going to be a tuple. And here we need a width and a height. And the height is the easy part, because the height for this rectangle is supposed to be the same as this rectangle. So all we really have to do in here is self.rect.height, and we are good to go. Now for the width, we have a bit of a problem, because in here, essentially, I had to measure how wide the actual pirate is in the sprite. And I found 50 pixels is a pretty good width. But this number I literally got from measuring the pirate in Photoshop. If you have a different sprite, this number is probably going to be different. With that, we have our collision rectangle. And this is then going to be the rectangle we use for the actual collision in our level. And this is also going to be the rectangle we will actually control in the game. And then this rectangle here, so the actual sprite rectangle, okay, that's a terrible line. This rectangle here is always going to follow this rectangle. So we can still use this one for collisions as well, which is also kind of useful for coins and enemies. So with that, we have to figure out how to make this rectangle always follow this collision rectangle. And this is going to happen, let me minimize the init method. This is going to happen inside of our animate method. And in here, we actually have to change quite a few things. The most important one is that this entire code chunk here that took quite a while to create early on, we can just get rid of entirely, because we don't need it anymore, because we always keep a static rectangle. So let me remove the white space. And now what we have to do. In this part here, we are checking if the player is facing right or facing left. And in here, I want to add some code to make the rectangle of the sprite follow the actual collision rectangle. And well, essentially all we're going to need in here is if our player is facing to the right. So this is our default position that we can work with already. Because right now, let me draw this again. If this is our entire player, right now we are placing the collision rectangle something like this. So if our player is facing to the right, so this way, we can make this work. And this is the setup we already have. Now the problem we have is that if the player is facing to the left, so something like this, for this we have to make some extra adjustments, but this comes in just a second. For now, let me get rid of all of this. What I want to do in here, I want to get myself .rect.bottom left and set this to self.collisionRect.bottom left. And let me add a proper dot in here so we don't get an error. That is not a dot. So really all we're going to do here, we take the rectangle of the sprite class, and from that we take the bottom left and set this bottom left to the bottom left of our collision rectangle. And this happens on every single frame. So, well, every single time our game updates. And that way, our rectangle is always going to follow this collision rectangle. So later on, when we control this collision rectangle, our player is going to follow this point. I hope that makes sense. But now we have to do the same thing for the other side. And this one also isn't that difficult, because essentially I can copy all of this and just change from bottom left to bottom right. And the same for the bottom right here. And I assume this is still going to be kind of confusing. So let me explain it again. So basically this is the rectangle for this sprite. And inside of this, we want to create another rectangle like this that covers the pirate. And what these two lines are for, so this one and this one, is to make the pink rectangle follow the yellow rectangle. Now, the adjustments we do have to make here is that if our player is looking left or right. And for that, we have bottom left and bottom right. So that if our player is facing to the right, so this way here, we are placing this bottom point so that the sword in the player that is going to be only in the pink one faces to the right. But if we are facing to the left, so if our player is facing this way, we are placing this bottom point here. So this pink rectangle would look something like this. And this would be this bottom right here. But all right, now we essentially have a system where our sprite rect is always following this collision rectangle. So with that, we have to actually update the position of this collision rectangle. And this means that whenever we change the position of this self.rectangle, we have to change the code to instead change this self.collisionRect. And inside of our player, there's one more place where we have to do this. And that's inside of self.gravity. Because in here, we change the rectangle. And this, instead of the rectangle, should be the collision rectangle. And that, I believe, are all the parts we actually had to change. So this way, our player is going to fall down and, well, the system is still working. But now to control the pirate with player input, we have to go to our level. So this level here. And in here, we have our level class that is getting quite extensive. But there are two methods that are really important here. And that is the horizontal movement collision and the vertical movement collision. Because in here, we are actually changing the player rectangle. And we are doing this in quite a few different places. And well, what we essentially have to do is to change all of this from player rect to player.collision rect, or at least most of them. So instead of using, let me go back to the player. Instead of using this self.rect attribute, we are using this self.collision rect attribute. So this line here has to change. Then the collidable sprites, they are still fine. For sprite, this one is fine. But then if sprite rect collide rect, this should be player.collision rect. And then if player.direction.x is smaller than 0, we also want to make some updates in here. Because this should be player collision rect, but the rect here is still fine. And then the same for the other side. Now what we can also do is to get rid of these two parts here. Because now that our rectangle is static, we don't have to update the origin point anymore. So all of this can also go, which makes our code a good bit easier. And this was the horizontal movement. We also have to do the same thing for the vertical movement. And in here, we have to start with this sprite rect collide rect. Now we are looking at the player.collision rect. And then it should also be this and this rectangle. And then for this part here, we can remove the on ceiling. So this part we don't need anymore. However, the player on ground we still need because that is important for the jumping. So if we didn't include this part, our player wouldn't be prevented from jumping once he's already in the air. And all right, this is, I think, all we needed. And that was probably quite a complicated part. And I don't think there was an easier way to explain this. So let me actually try this and see what we are getting. So let me jump down here. I can still jump on the enemies. That still works just fine. And now my sword can overlap with the other obstacles. And this wasn't possible in the previous parts. And now I can also try to jump against other collision objects. And I think this is looking good. So now it looks much more like our pirate is colliding and not the sword is colliding. So that's a good upgrade. Now there's still a couple of problems. The most important one is that for the animation for our pirate, it looks like the pirate is jumping every few frames. So that's a thing we do have to work on. And this happens back in the player, and more specifically in the animation part. And essentially the problem we have here is that Pygame always tries to put the self.image in the top left of self.rect. So we have to work with that. And really all that means at the end of self.animate, we have to put self.rect is equal to self.image.get underscore rect. And in here, we want to place the mid bottom. And this should be where our self.rect.mid bottom was in the last frame. And now let's try this again. And now we're getting an error. That name self is not defined in our player. Let's have a look. And it's in our player. And the problem is that this should be indented one more time. And now let's try this again. And there we go. Now the pirate is animating properly. We can still jump on the enemies. We can collide with palm trees. That is looking pretty good. Cool. Now there's one more thing I do want to work on. That whenever we jump and land, the dust particles are in front of the level. So if you look very closely, this looks actually kind of bad. That whenever we land or fall, the dust particles are in front of the grass, which is, I think, looking a bit bad. And this could actually be a pretty good exercise for you. Change the code so that our dust particles are being drawn behind the level. And this should be a very easy thing to change. all we have to do in our level file, let me minimize everything else again. We have to look at our run method. And in here, we have a ton of different things. The one I'm looking for is this part here, the dust particles. And right now, they are drawn in front of quite a few other things. So our terrain is all of this. On top of that, we're drawing the enemies, then the crates, then the grass, then the coins, then the palms, and then the dust particles. So really, all we have to do is to move all of this before we are drawing the terrain here. And let me fix the white space. And there we go. Now our terrain is drawn after the dust particles, meaning that our terrain is on top of the dust particles. And well, that's all we needed, I think. Let's try this now. And let me jump down here. That's a bit annoying. There we go. There we go. That is looking a little bit better. So a difference here is quite minor. But if you have seen the earlier parts, this is looking better. A very small thing, but a small thing that did annoy me. So, all right, with that, we have much better collisions. Now, the collisions still aren't perfect. There are occasional bugs. But for this game, I think this is good enough. But if you wanted to fix them, you would essentially keep on playing around with this and find more and more bugs and fix them. And for an actual video game, you would have a whole team playing the game all day and testing the different bugs. And even professional games have quite a hard time to fix every single edge case. And if you watch speedruns, people exploit these bugs quite extensively. And this happens for basically every game. So there are always going to be bugs that are quite difficult to fix. But in my case, I think it works in like 99.5% of the cases, so I'm quite happy with this. But it definitely is not perfect. But with that, let's work on the second problem. That once we are getting into the overworld, I want to prevent the player from moving for the first couple of milliseconds. Now, why is that relevant? Well, let me actually demonstrate. So here in the code, let me run the game and let me go to level 2. And in here, let me just jump into the water and I keep on pressing right. And essentially, I fail the level and the player moves immediately from level 2 to level 1. And the essential problem we have right now is that the last input in our level is also being captured by the overworld. And that means that if you finish a level, you might move automatically, which we don't want. And the easiest way to fix this is to just give the overworld a very short timer that we can only give keyboard input once this short timer has passed. And this short timer is only going to be a few milliseconds. It's very, very short. And implementing this is really, really easy. And this happens in my overworld. And in here, I have my node class that I don't care about, and I have my icon class that I also don't care about. And let me minimize all of this, because we don't really need most of this. All right, I want to work in my init method for now. And in here, I want to create a new section. And let's call it time, I guess works. And for this one, I want 3 attributes. I want self.start time. And this is just the start time when our overworld starts. And to get the time, we need pygame.time.get_ticks. Now, next up, we want another method that I have called self.allowInput. And by default, this one is going to be false. And essentially what we are going to do is in the input, I'm going to check if self.notMoving and self.allowInput. So we can only get input in the overworld if the player is not moving and if self.allowInput is true. So right now, we would not be able to get any kind of input because this is false. But in a second, we are going to create a method that will change that. But finally, I want another attribute that I called timer length. And in my case, I have set this to 300, so 300 milliseconds. So now I can minimize all of these and create another method. And let's call it input underscore timer. It doesn't need any arguments besides self. And in here, I first want to check if not self.allow input. So if this method here is false. And if that is the case, I want to get my current time, which is pygame.time.get underscore ticks. And now I have my current time and my start time. And those two numbers I can use to create a countdown timer. And we have actually created one earlier in this tutorial. That happened inside of the player. Specifically down here. And with that, I think this could be a pretty good exercise for you. So I want you guys to create a timer at the beginning of the overworld. And this timer, after it's finished, should set self.allow input to true. All we are going to need is if our current time minus self.start time is greater or equal than self.timer length. And if that is the case, self.allow input is going to be set to true. That's literally all we needed. And I guess just to explain this timer really quick, think of as this is our timeline of our entire game. And self.start time we get whenever the overworld is being created. Let's say right now it is this point here. And then from this point, we are getting our current time. So from this point, we are checking this time here, this time here, this time here, and so on. Because this current time is being checked continuously as long as our game is running. So this number is increasing, whereas the start time always remains constant. And at some point, we are going to reach a certain distance here. And as soon as this distance is greater than this timer length, this if statement is going to trigger. And that is basically a timer. Now, the last thing we do have to do, that is very easy to forget, is we actually have to call this method. So self.inputTimer. And now let's try all of this. And actually, when we start the game, we can practice this. So let me run the game, and I just pressed to the right, and it took some keyboard presses to do this. And actually, we can test this a bit better. So in the overworld, I'm going to set the timer length to 3000. So we have to wait 3 seconds before we can move. And now let's try this again. And now I'm pressing to the right in the game and nothing happens. Only now something happens after 3 seconds. So this is working pretty well then. And now I can set this back to 300. And essentially now, if I run the game, let me go to level 2 and jump into the water. I keep on pressing left. And there was this slight offset in our overworld. And this means that if the player presses a button in the level, it doesn't really translate to the overworld unless we keep on pressing for kind of a long time. But if we are doing that, we would assume the player wants to go in that direction. So this is then also pretty good. Cool. So with that, we have one more thing to work on, and that is to add the sound. And well, that is the part that should be the easiest, because all we need is to import a couple of sounds and play them under certain conditions. So for example, if the player is colliding with a coin, we are playing the coin colliding sound effect. But first of all, to work with the sound, we need some sound files. And this we now have. Because now, if you check the project files, there's a new folder. It's called audio. And inside of audio, we have a level music and an overworld music and a folder called effects. And inside of that, we have 4 more files. They're called coin, hit, jump, and stomp. And well, they do what the name implies. It's quite straightforward. So now all we have to figure out is how to play all of these sounds inside of our actual game. And well, that honestly isn't all that difficult. And I guess we can start with the sound effects, and once we have those, we work on the background music. And let's do all of this straight in the code. That should be the easiest way to approach this. So here we are back in the main file, and I want to start in the level. And in here, there are two sound effects I do want to play. And that is the coin effect and the stomp effect. For the simple reason that in here, we already have two methods that are called check coin collisions and check enemy collisions. So we can use those two methods very easily to play the respective sound. But before we can do that, we first have to import the sound. And that is going to happen in the init method. So in here, I'm going to add, let's do it right at the top. I want to add another section that I called audio. We have to first create a new attribute. Let's call it the coin sound. And to create a new audio file, we need pygame.mixer.sound. And it is really important that the sound here is capitalized. So don't forget that part. And this sound is going to need one argument, and that is the file path to the actual file, which in my case is this one. And with that, we have a sound. Now we have to do the same thing for the stomp sound. So let's call it stomp sound. And this is just pygame.mixer.sound again. And now the file path is going to be this one here. And I guess we can run the code, go into level, and we don't get an error. That's a good sign that the import worked just fine. With that, we can minimize the init method and now go to these two methods. And let's start with the coin. So in here, I want to play a sound whenever we collide with a coin. And inside of this method, you have two choices. You could either play the sound in here, or you could play the sound in here. Both would be fine, I suppose. The difference is that if you play the sound in here, if you collide with two coins, you're going to play the sound twice, which I guess would be fine, but I don't really like that. I only want to play the sound once. But play around with this, whatever works best in your game. But to play a sound, all we need is in this case self.coinSound, I think I called it. Yep. And we want play. And then for the enemy, we have to do something very similar. And this could actually be a pretty good exercise for you. So what I want you to do is to play the stomp sound whenever the pirate jumps on an enemy. Now, this part is actually quite easy, because inside of this if statement, we know that the pirate jumped on an enemy. So if this is true, we want self.stompSound.play, and that's literally all we needed. So I guess now let's actually try this. So I'm back in the game, and let me stomp on a player, and there you could hear both actually. So if I go on a coin, you can hear coin sound, and if I wait for an enemy, we get a stomp sound. So that is working perfectly fine. Cool. So with that, we have the first two sounds. There are two more, and that is the jump sound and the hurt sound. And both of those are going to happen inside of the player. So let's go to the player. And in here, we have to work in the init method again. And let me add another section in here that, let's call it audio. And what I want to create in here is self.jump_sound and is self.hit sound. And in both cases, this needs to be pygame.mixer.sound. And the only difference between the two is the file path. So for the jump sound, it is this one. And for the hit sound, it is this one. And well, by now, you should be fairly familiar with the file path. So I hope this makes sense. Once we have that, all we have to figure out is when to play either of these sounds. Actually, let's do an exercise for this. So figure out yourself when to play the jump sound and when to play the hit sound. Should be fairly straightforward. I guess let's start with the jump sound. And we already have a method that's called jump. So in here, self.jumpSound.play. And let's try this one. And this is pretty good. Although, arguably, the sound is slightly annoying. But, well, it does work for our game. And with that, we have the jump sound. So next up, we have to get the get damage sound. And we literally have a method that triggers damage. So in here, I want to also play self.hitSound, I think I called it. Yep. And play this one. And now let's try all of this. Let me get hit by an enemy. And this is also working. All right, so with that, we have the different sounds. Now, I guess one thing you could also do, let's say in the player, let me minimize all of this, and let's open the init method again for audio. Let's say you find this jump sound a little bit too loud, which I could totally understand. What you could do is target the jump sound again and set the volume. And then here you can set a number between 0 and 1, with 0 being no sound and 1 being the full sound. So if you have 0.5, you would have a volume of 50% for this sound here. And I guess let's try this again. That does feel a little bit better. It's very hard to tell. Basically, play around with the sound. This might take you some time, but that's something beyond this tutorial. So in my case, I can minimize all of this and we are basically good for the sound effects. Now the last thing we are going to need is the background music. And this I'm going to organize inside of my game class. So in here, I'm going to add, let's call it audio again. And I want to have self.level underscore, let's call it BG music. And then besides that, I also want self.overworld, that's not how you spell that, underscore BG underscore music. And this one is going to be the same principle. So pygame.mixer.sound. And now all we need are different file paths. For the level, it's going to be this one. And for the overworld, it is going to be this one. So now we have the two different pieces of background music. The one thing we have to figure out now is when to play them. And we actually have two different methods that we can use for that. So we have create level and create overworld. However, by default, we don't call either of them. So when we first start the game, we don't call create overworld. Instead, we create our overworld right here. Hence, in our init method, we already have to start playing the overworld BG music. And I guess I could reorganize the code a tiny bit to make this a bit more consistent. So let me move up the audio a bit. And now, when we create the overworld, I can play self.overworld BG music and add play here with loops being -1. And don't forget the -1. And so far we didn't need this argument, but really all that it's doing is that when this music file finishes, we are starting it from scratch. So we are essentially looping it indefinitely, which is what the -1 is for. If this was a 2, for example, we would be looping this sound twice, which we don't want. We want this to run forever. So now when I start the game, we should be hearing a sound. So this is already working quite well. So now what we have to do is when we create a level, we want to stop the overworld music. All I want to do is self.overworld BG music.stop. And now let's try this again. And that is indeed no more music. And the other sounds still work just fine. Cool. But obviously now we don't have any level music. And that we can also add in here. So I called this one level BG music.play. And again, we need loops being equal to -1. So now let's try this again. And all right, this is also working. So with that, we have our level. Now, next up, when we create the overworld, we kind of have to do the opposite. So we want to stop playing the level BG music and instead start playing the Overworld BG music again. And I guess this could be an exercise for you. So update the create overworld method to only play the overworld music and stop playing the level music. And this step should actually be fairly easy. So let me just copy the overworld music, and in here I want to play this one again with loops being equal to -1. And then the self.bg music should just stop. And well, now let's try this again. And that is working pretty well. So with that, we have the background music for the different stages of our game. Now there's one more important thing, and that is the check game over. Because the problem we might have in here, that we are in the level and the player dies. As a consequence, we go back to the overworld, but we don't stop this background music. As a consequence, we have the music for the overworld and for the level. And well, this can be fixed quite easily, because let me copy it from the overworld. All we want to do is to stop the level music once we are losing the game. And I guess let me test this in the game itself. And alright, this almost works. The one thing we have missing now is that we don't play the overworld music anymore. So that is the last thing we have to add in here, that we want to play the overworld music. And well, all you need for that is to copy this line again. And now for the final test, let's run this again. And with that, we have a proper audio setup. And this is also finishing up the entire series. And this did become quite a bit longer than I originally expected. But well, I hope you enjoyed the entire series and you got something out of it. But thanks for watching it, and I will see you around.